Okay, guys, so we'll now move on to the next part of the lesson, the standard normal distribution. Okay, so, okay, guys, so let's see what's happening here. So it is often useful to standardize normal distributed random variables. Okay, so you do this by coding the data so that it can be modeled by the standard normal distribution. So guys, the thing is when you're working with real life data or when you're working with, when you're actually working with data sets and you find the mean and standard deviation, okay, you're not always going to get a mean of 0 and variance of 1, because if you recall this in all the previous exercises we did, exercise 7b and 7c was entirely done for a normal distribution with mean 0 and variance 1, right? That was what we called as the standard normal distribution. The Z letter, the letter capital Z here represents the normal distribution with mean 0 and variance 1. Okay. But the thing is, when you're working with real life, you don't always get a mean of 0, right? So when you're working with some real data, let's say you work with some X data, you might have some value for your mean and you might have some value for your variance, right? It's not always going to be 0 and 1. So now what we are gonna look here is we are gonna see a technique to convert. So this is what we call a normal. This is the normal distribution, okay, with mean mu and variance sigma square. So what I want to do here is I want to convert, okay, I want to convert the normal distribution to standard normal distribution. Can you see? This is what we want to do. We want to convert the normal distribution to standard normal. Okay, so that's the conversion they give you, and this is the way you convert. So how do you convert your variable x from normal to standard normal? So the way you do it is z is equal to your variable x, you have to subtract it from your mean and divide by the standard deviation, not the sigma square, but from the sigma. So this is very important, guys. Okay, so this is really important. Basically, this is how you convert the normal distribution to standard normal, and this is what we are going to use mainly. Okay, so this is the main conversion. Okay, whatever your variable, you subtract it from its mean and divide by the sigma value, and immediately you get the standard normal distribution. So when you come back to the z state, that means you can go with these methods. Okay, you can use exercise 7b and 7c techniques when you have the z variable. Okay, because you know you have the table at the back of your book is only given for mean 0 and variance 1, right? It's not given for different means. Otherwise, for different means, you'll have to have different tables. So that's not practical, right? You can't have like different tables for different means. So we need to work with one table. That's easy. So then whatever the mean and variance they give you, we need a method to convert this guy. So basically, when you do this conversion, this becomes a normal distribution. So now you have a normal distribution with mean 0 and variance 1. So when you do this conversion, you get this. You come back to the standard normal. Okay, guys, so that's very important. Okay, now let's see how to apply this in sums. Okay, so now let's go for the applications of this rule. Okay, so they in exercise 70 question number 1, they tell the random variable x follows a normal distribution with mean 20 and variance 4. Okay, so you're supposed to find the probability that x is less than or equal to 26. Okay, I just want to give you an idea of what's happening. Now, in this normal distribution, the mean is 20, not 0. Can you see? So the mean is 20. Can you see? You need to be able to draw this as well. Mean is 20. And so you need to find the probability that x is less than or equal to 26. So 26 is over here, right? You need to find the area behind 26. Okay, but you know, you don't have a table with mean value 20, right? We only have the standard normal table with mean value 0. So then this doesn't work, guys. So what you need to do is you need to convert this normal distribution with from a mean of 20 to a mean of 0 and from a variance of 4 square to a variance of 1. Okay, so we need to do the conversion. How does the conversion work? I need to move this to have a mean of 0. Okay, so basically I want to convert the x variable to a z variable. So how does the conversion work? This is the way the conversion works. Okay, so let me write the sum. So what's our sum? You have to find the probability x is less than or equal 26, right? This is what you need to find. So how do you convert, guys? Look at the way we convert. First, I'm going to replace x. Who is x? The way we replace, no, sorry, I'm not going to replace x. I'm going to build z. I'm going to build z. How do I build z? From x, from this guy x, you subtract the mean. You subtract the mean and you divide by the standard deviation. I'm just going to apply this rule. Okay, to x, I subtract the mean and divide the standard deviation. And then the less than or equal mark, the less than or equal mark is what I have over here. I'm just rewriting the same sum, guys. Okay. From x, I subtract the mean and divide by the standard deviation. Do the same thing to the other side. Now, what do I have here? 26 is the value. From 26, you subtract the mean. From 26, you subtract the mean. The mean value is 20. Can you see? The mean value is 20. Okay, you subtract 20 and you divide by the standard deviation. Now, you know this 4 square is the sigma square, right? 4 square, the sigma square is 4 square. So, just sigma should be 4, right? Just sigma should be 4, right? Can you see what's happening here? So, you subtract the mean. Okay, so you subtract the mean. That's what I have here. The mean value is 20 and you divide by the sigma. And you divide by the sigma. So, the sigma value is what I have over here. It's the same sum here, guys. What I did is I wrote the same sum. X and 26 is there here. Do you see? The x is there here and the 26 is there here. But to both the sides, I'm doing the same operation to both the sides. You know, if you're doing the same thing to both the sides, you're not doing any change, right? I'm doing the same operation on both the sides. I'm subtracting the mean and dividing by the sigma. Okay, guys? So when you do this, what do you get here? This becomes x minus mu over sigma is our z variable. This is our z variable. So z is less than or equal. Shall we get the value? 26 minus 26. 6 divided by 4. Can I have the decimal? 6 divided by 4. That's 1.5, right? 3 over 2, 1.5. So is that less than or equal 1.5? So guys, this is something that's this is something that you are very familiar with. This is exercise 7b. This is exercise 7b. So you can see what has happened here, right? The same graph. Now the 20 is becoming 0 and the 26 has become 1.5. The 26 has converted to 1.5. Can you see what happened? What actually went here? The 20 became a 0 and the 26 is what became 1.5 in the standard normal table. Okay, because you converted the 20 here, right? So in place of 20, the mean becomes a 0 and in place of 26, you get the value 1.5. So you have to find the area behind 1.5. And you can do that. So that's the first table, right? So we go for our first table of normal distribution and search for the probability behind 1.5. So I think this guy, right? 1.5, Z value 1.5, 5Z is the area behind. So now we have the Z value. So this is exercise 7B. Where you have the Z value, you find the area behind. So area behind is 0.9332. So which means this the answer here is 0.9332. Okay, guys? Okay, guys, the area behind is the 5Z value. So I just wrote that also. Okay, let's do a few more sums and get ourselves familiar with this. Part B, probability x is greater than 30. Okay, you have to find a probability x is greater than 30. So if you draw the graph, the mean is 20. You don't need to always draw this, but I just want to always give you a visual idea of what's going on. This is 20. Here you have 30. You need the area in front of 30. This is what you need. So you know what you do here? You convert this normal distribution to a mean 0, right? Instead of 20, you need to convert to 0. And you have to see what is the value for 30. What is the new value of 30, right? That's what we need to find. Because 20 became 0, the mean, and what's the new value we get for 30? So how do you find the conversion? Probability x greater than 30, you write as probability. From x, you subtract the mean, divide by sigma. Write the greater than sign as it is. From 30, you subtract the mean, that's 20, divided by the sigma value was 4. Sigma square value was 4 square, sigma value is 4. So x minus mu over sigma is the z value. X minus mu over sigma is the z value greater than 30 minus 20, that's 10. 10 divided by 4. So that's 5 divided by 2, that's 2.5. So you can see now this value 30 has become a 2.5 in the standard normal. In the X distribution, the value 30 has become the value 2.5 in the Z distribution. Okay, guys, so you need to find the area in front. Okay, so exercise 7B, we are using the first table, so you can't get the area in front, right? I mean, you can't direct that table, only gives you the area behind. So if you want to find the Z greater than 2.5, you do the conversion. Do you recall? Probability Z greater than 2.5 is 1 minus probability Z is less than 2.5, right? So you get the area behind and subtract it from 1 to get the area in front. So let's go to get the area behind. Is that less than 2.5? Let's get it. 2.5. Z value 2.5 is here, right? 2.5. 2.50. Is Z value 2.50? The area is 0.9938. Can you see? For 2.50, area is 0.9938. And then you subtract it. So 1 minus 0.9938, 0.0062. Yeah. Okay, right? Part C, probability X is greater than or equals 17. So that is, your mean is 20, right? So 17 is behind. And you need to get the area in front. So now you need to do the conversion and see the 20 becomes a 0, which means I think definitely this 17 is a negative A value, right? So you have to see what's the negative value corresponding to 17, okay? So doing the conversion, X greater than or equals 17 is equal to probability X minus mu over sigma greater than or equals 17 minus mu is 20 divided by sigma is 4. This is probability Z greater than or equals 17 minus 10, that's 3 over 4, that's 0.75 minus 0.75, right? 17 minus 20 minus 3 over 4 is minus 0.75. So you need to get the area. So the 17 corresponds to minus 0.75. Agreed, guys? Okay, so that's the new value for 17 in the standard normal distribution. Now, how do you get the area behind in front of minus 0.75? You know the table doesn't work for negative value. I have told you the method to convert negatives to positive. How do you convert? Directly, you don't need to do any 1 minus here, right? When you're converting negative to positive, it just converts. Is that the greater than becomes less than or equal, minus becomes plus. Direct conversion, right? Sign is changed, the inequality mark flipped and the sign changes. Okay, now is this in the format of the first table? Yes, this is directly in the format of the first table because it's in the less than format and A is positive. 0.75 is 0.7734. Okay, so that's it. So the answer here is 0.7734. Okay, guys. So I think this should be very clear with you all now. Okay, guys. So now you know the method of finding the probability when the Z is given. So now let's go for question number 4. So here you can see the difference is, okay, you can first see there's a normal variable, mean 30, variance 25. Okay, so remember this 25 is sigma square. Okay, if sigma square is 25, immediately sigma is root 25. So sigma is 5. Make sure you do this immediately, okay? Because if you use the wrong sigma value, the sum is wrong. Okay, this is the sigma square value is 25. So sigma is 5. Okay, that's number 1. And then they want you to find the value of A such that the probability Y greater than A is 0.30. Okay, guys. So in this case, you can see the probability is given. They want you to find the inside value. Okay, so again, you can kind of like start the sum. You can draw, you can draw this. The mean is 30. And guys, you can decide if your A value is bigger than 30 or not, right? Even like at this stage also, I think you have the knowledge to do this, right? Right, guys, because you know now here your mean is 30. So y is the normal distribution here with mean 30, variance 25. So y greater than A is 0.3. Now, you know, when you see a 0.3 area, it's a small area, right? And it's a greater than. Greater than means you're shading to the right side, the bigger side. So you guys should be able to understand here A is on this side, right? So you see, because at this point you need to be able to identify certain things. So I know definitely A is on this side and this is a small area that I need to shed for the greater than side. And then that tells me that my A value is bigger than 30. Can you see? I know that from the beginning itself, my A value is bigger than 30. So you know what we are going to do now, right? What's the next step? We are going to convert this distribution to a normal distribution. So when you convert this distribution to a normal distribution, the mean value 30, it becomes 0. 30 becomes 0. Okay, and then you need to see what happens to this A value. Okay, what happens to the A value? And then, the area in front will not change. Even if you convert it to a normal distribution, the area in front 0.3 will not change. Okay, regardless what distribution, whether you convert, the area doesn't change, only the values on the axis are changing. Okay, so 30 became mean 0. Okay, this is the Y distribution, this is the Z distribution. Mean 30 became mean 0. Now I have to see what happens to A. So shall we do the conversion, guys? So how does the conversion work? From Y, you subtract uh, the mean, right? Y minus mean divide by sigma. That's how you do the conversion, right? From your X value, or here in this case Y value, you subtract mean divide by sigma. And here the greater than sign, so keep the greater than sign. This is A minus, what's the mean value is 30 divided by what's the sigma value? Sigma value is 5 equals 0.3. This doesn't change. Let it be here. So then you get here probability Y minus mu over sigma from the variable. When you subtract the mean and divide by standard deviation, that is it. So guys, over here, we don't know the A value. So you have to go like this. Do you agree with me? So this is your new variable. Now previously was A. So now what's the new value? In this new graph, the new value is A minus 30 over 5. And you know A minus 30 over 5 is a what value? Because you drew the graph at the very beginning itself, you know it's a positive value. Okay, you know it's a positive value. If you want, you can use it as maybe give a letter for it. Is it greater than or equal to maybe some simple x? If you want, give a simple x here. Okay, just give some letter. And now, don't you know to find this x value? So this is the exercise 7C, right? So the greater than area is given to you, and you can see with this probability value. I told you when you get probability values to 1 dp or 2 dp, you don't have to go with the first table, right? We can go with the second table, because in the second table you get these nice probabilities to 1 dp. And if you are using the second table, you need to have a positive value here. This has to be a positive figure, and you need to get the area in front of it. So I think we have everything ready for that, right? We have a nice probability value to 1 dp, and we have an area in front of the x value. So can't we get this x figure? So let's go for the second table. Second table. First table doesn't work here, right? Second table, the area in front, is that greater than, it's a simple, is that is 0.3. Do we have 0.3, guys? Yes. Can you see? So for 0.3 area in front, the corresponding Z value is 0.5244. Can you see? So guys, what they are saying here is that this value here is 0.5244, right? That's what you have here. So which means what? This simple x, or in other words, you don't need to input x here, okay? It's not actually necessary, but this is 0.5244. That's what happens at the end of the day, right? This A minus 30 over 5 is a 0.5244. So let's get the A value. A minus 30 is 0.5244 times 5, and then you add the 30, right? So what's the answer? So you should definitely see your A value bigger than 30 to make sense. Okay, so what did we get? Okay, guys, let's move on to question number 6. So let's make it a little bit more challenging now. The random variable y follows a normal distribution with mean 100 and sigma square is 225. Okay, which means sigma is square root of 225, which is 15, right? Find the values of s and t such that, okay, part A, the probability y greater than s is 0.975. Shall we mark this on the diagram? So how does this work? You know, you have a normal distribution with mean 100, right? The mean is 100. So y greater than? Greater than means you're shading the area in to the right side. You're shading the area to the right side, and that area has to be 0.975. 0.975 means it's more than half the area. So you have to make sure you're shading to the right side and it covers more than half. So what does that tell me? It tells me that the S value is behind, right? Behind 100. Then when I shade the area in front of S, I can get a 0.975 area. Do you understand? That's the first thing to see. Because 0.975 is definitely bigger than 0.5. So that tells me, and because I had to go y greater than, I had to shade to the greater than side, I understand S is behind. Okay, S is behind 100. So what does that tell you when you convert to standard normal? So that tells you that when you convert to standard normal, the 100 becomes a 0. And this S value is surely, guys, it's surely negative. So I'll just mark minus X here because you know this is converting to a new value, right? This S converts to a new value. And that new value is definitely negative. Do you understand? Okay, so let's do the conversion. Probability Y greater than S. We need to show this so that they see. So from Y, you subtract the mean and divide by sigma. And now this is the conversion of S. So from S, you subtract the mean and divide by the sigma is 15, right? The sigma is 15. This is equal to 0.975. And now what do you know? Probability Y minus mu over sigma is Z. S minus 100 over 15. You know this is minus X. You identified. We know it's minus. We know it's negative because we identified it from the graph even before we started the sum. So if it is minus and when you have this area, you know that you want to make it positive. Okay, so immediately we know that, so what do we do here? You can convert greater than to less than, make it positive X, and this doesn't change, right? Do you agree with me? So greater than you turn to less than, the negative becomes a positive X. Okay, 0.975. So now this is in the format of the first table. So is 0.975 there in the first table? Let's check if that value is there or if we need to go for the second table. Okay, so 0.9750 is there in the first table. So that's good. So we can go with this 1.96. Okay, guys. So which means the X value here is 1.96. Okay, but then you know the real X value is negative, the one that we started off. Okay, so for the value that we require, okay, is actually minus 1.96 because this is after the conversion. Okay, but before the conversion, the X value is minus 1.96, which is S minus 100 over 15 is minus 1.96 because you use this X for this guy. So this is the negative value, right? This S minus 100 over 15 is the minus 1.96. Okay, you don't even need to put these X values if you understand that this is negative. This is the negative value. Okay, so you can now get the S value and you know your S value should be what? Smaller than 100 because you identified that from the beginning. You know that your S value is smaller than 100. So S minus 100 equals minus 1.96 times 15. So S equals minus 1.96 times 15 and you add the 100. So get the S value, guys. Okay, so you should get a value smaller than 100. How much is it? Okay, guys, so 70.6 and you can see your answer makes sense with your diagram because you know your S is smaller than 100. Okay, that's done. Moving on to part B. Probability Y less than T is equal to 0.10. Okay, so now again, let's identify things from the very beginning so it makes things easier for us. Okay, so you have a normal distribution with a mean 100, right? Mean is 100. Now decide where T is. Is T behind 100 or bigger than 100? Now, how do you shade the area? You're supposed to shade Y less than T. Less than means you have to shade the area to the left side. Y less than T, the area you're shading to the left side is 0.1. So guys, if you're shading an area of 0.1, 0.1 is smaller than 0.5. So that means you're only shading a small portion. If you're shading a small portion, you can see that it doesn't make sense to mark P here. Right? If I mark P here and mark area behind is very large, it's more than half. So it makes sense that P is behind 100, right? Because you're shading the area Y less than T. So this makes sense. You see, so this area is 0.1. Okay, guys. So then number one, we identified the T is behind 100, and that tells you, what does that tell you? That when you convert to standard normal, you know what's going to happen, right? The 100 becomes the 0, right? It's the 100 that becomes the 0, which means your T value is going to become a negative X, a negative, some kind of a negative converted value because it's behind 0. Okay, so let's get started. So we have identified things from the beginning. So probability y minus mu over sigma, this is going to be T minus mu was 100, right? Sigma is 15 equals 0.10. So probability y minus mu over sigma is z, T minus 100 over 50. You can leave it as it is. You don't even need to input new variables if you want. And we know this is the negative x value. Okay, maybe I'll go for that. If you understand, you can reduce a certain amount of steps, guys. Okay, if you actually get what's going on here. Okay, so now I have z less than x. Okay, and you know now, I think you can see with this 0.1 area, I feel like it's something we can go with the second table, right? Not the first table. The second table deals with these kinds of nice small probability values, right? With 1 dp, 2 dp. You can work with the second table. But the second table, in order to use the second table, you need to have z greater than, the equal sign should be to the greater side and the x value should be positive to use the second table. So you can do the conversion directly, right? So z, the less than becomes a greater than, the negative x becomes a positive x, right? This is the way you convert. Conversion is done. So now what do you do? Go to the table, go to the second table. Okay, so we are in the format of the second table. 0.1. Second table 0.1. Can you see its z value is 1.2816. Okay, 1.2816. So your x value here is 1.2816. Maybe don't write x as 1.2816 because you know that this is what you want and this is the negative value, right? So maybe write like this. T minus 100 over 15 is minus 1.281. Because guys, this is what they want to see. Okay, so this is because you know this is the negative value. So the real value you want is minus 1.2816. So minus 1.2816 times 15. So T equals minus 1.2816 times 15 plus 100. Okay, guys, and you get the P value. So how much is T? It should be something smaller than 100. Sorry, it should be something, yeah, smaller than 100, right? Yeah. How much is it? Okay, guys, so you get 80.776. Makes sense, right? Okay, so that's your T value. So that's done. Part D is done. Find the values of S and T. Then moving on to part C, write down the probability Y is greater than S and smaller than T. So guys, how do we do this? Do I really need to convert this back to normal standard normal to do this? You know, even if you have this in the Y distribution, you can still draw the diagram and still mark all the information and get the work done, right? Because you now know the S and T values. Okay, so actually part C, you can do it from a very simple diagram. You don't need to do any conversions or use any Z table. Okay, you can do this in a really easy method. The mean value, I'm going with Y, okay? I'm going with the Y variable. That's why the mean is 100. I'm not going with standard normal because I'm working with Y. Okay, I'm working with Y, the normal distribution which has a mean of 100. So what did we know about the S value? S value and T value, we found out our S value is 70.6 and we found our T value is 80.776. So let's mark it. We know our S value is 70.6 and we know our T value is 80.776, right guys? This is the S value. This is the T value. So this area. Isn't this what they want you to find? Find the probability y is greater than s and smaller than t. So this is the area they want you to find. Do you agree with me? This is the area they want you to find. How do you find this area? Let's use the help of part A and B. In part A, they have told you the probability y is greater than s. Can you see, guys? The probability that y is bigger than s. S is here. This is s, right? So bigger than s, the area is 0.975. This large area is 0.975. Guys, so let's do like this. Shall we get the area on this tail end? Let's not use this. Can I have the area on the tail end? How much is that? 1 minus 0.975. Can I have the area of this tail behind S? What's the answer? 1 minus 0.975 is? Let's get the area here, guys. How much is this area? 1 minus 0.975 is 0.025. Do you see? Okay, so we are using some tricks to make our life easier. Okay, so this area is 0.025. Okay, now let's use the help of the other one. What do they say here? In this one, the probability y is less than t in part B. The probability y less than t means, guys, it's this area, right? This is the t value. So probability y less than t means this whole area. So this entire region area is 0.1. So now, when you have all of this, can't you get what you want? Now you want the area between S and T, right? So can't you easily get the area between S and T now? Can't you easily get the area between S and T? All you have to do is take 0.1, that's the area completely behind T, and subtract it from the area completely behind S. Do you agree with me, guys? It works, right? From the area completely behind T, if you subtract the area completely behind S, you get the area between S and T. So using the information they gave you earlier. Okay, guys. So what's the answer? 0.075. Okay. All right.